If she calls again, then I'll answer. Okay. So, step 1, pick either equation, x or y, doesn't matter. Got to get the x by itself or y by itself. So we picked the second equation, got the x by itself. You take the other equation and you rewrite it, but if x is equal to this, we're going to rewrite it, but we're going to replace the x with what it equals. What's step 3? Solve this. What's the next thing I got to do to solve this? Distribute. So I'd get negative 2y plus 14 plus y is equal to negative 4, right? After you distribute. I got a negative 2y plus a y. What's negative 2 plus 1? Combined like terms. That'd be negative 1y plus 14 equals negative 4. Minus the 14. So you get negative y equals negative 18. So what's y going to equal? The negatives will just end up canceling and be positive 18. What does that mean about my answer? Remember, for every single one of these solving systems problems, what is the answer going to look like? For every single one of these problems, what's the answer look like? It's a point. So we're looking for that point. Do we have the whole point now? What's the only part we have? We have the y variable is 18. See, how do you find the x that goes with it now? You pick a spot. You can go first equation, you can get second equation, or I recommend right before you substitute it. The place right before you substitute it is typically going to be the easiest place to substitute in because it's already going to be solved for the other variable. So if y is now equal to 18, x would equal negative of 18 plus 7. What's negative 18 plus 7? Negative 11. So there's your answer. Negative 11, 18. Should you still now be able to... Guys, why are we getting money out? Should you be able to check your answers? How do you check your answers for every single one of these problems? Just plug the points in. Does negative 11 plus 18 equal negative 7? Or sorry, does 18, negative 8. Yes, does negative 11 plus 18 equal negative 7? That's not right. What did we do wrong? Because that is not a true statement. We messed something up. How do we know we messed something up? Because it doesn't work. Because that does not work. So now we go back and we double check and we say, all right, hold on, let's double check our response here. Did we solve for x correctly? Yep, that'd be negative y plus 7. We plug that in. We distribute negative 2y plus 14 plus y, negative 4. Looks good. These two would be negative y. That looks good. I like this. Emily, do you see it? Oh, that's why. It would help if you copy the problem down from here to here correctly. That should be a negative 7. So that'll screw the whole thing up. But the general idea is the same. All right. Let's try another one. Let me ask you a question. For these problems that I give you, what are you hoping for? Huh? Either one that's already solved for x or y, or two equations that don't look like this. Why? with this problem that I put on the board. 4y minus 5x equals 9. X minus 4y equals 11. How many good choices do we have for step 1, where we want to get one equation, solve for x or y? We only have one here. What's the only real good choice? Second equation for x. This method is a really, really good method, but it's actually a method that I would not use all of the time, because there is something that tells me when this is a really good method. And that's when I see something like this, because I can easily take that x minus 4y equals 11, and I can complete that first step, where all I have to do, move the 4y to the other side. This to me is the most telling part of when should I use the substitution method. If you can get one equation by itself really easily, then this is a really, really good method. Because now all I have to then do is rewrite the other equation. So we got 4y minus 5x, but I'm not going to write the x. Instead of x, what am I going to replace that x with? 4y plus 11. To me, this is a really easy method, but it is a method that if you can't do the first step easily, it's probably not the best method kind of thing. So here we would distribute. The biggest thing to remember when you distribute here, you got to distribute the negative as well. Negative 5 times 4y would be negative 20y. Negative 5 times 11 is negative 55. And then we solve. What's 4y minus 20y? That'd be negative 16y. Somebody help me out with this one, because we got to do a division. So we got 16y equals, let's see, 9 plus 55 would be 64. What's 64 divided by 16? 4? Is it 4? Okay. So, what do I know about my answer now? We know the y coordinate, right? So, where's going to be the best place to plug that in? Here, here, or here? I would plug it in right before you substitute it. So we got x is equal to 4 times negative 4 plus 11. 4 times negative 4 is negative 16 plus 11 is negative 5. Now, here's a little tip. You want to check your answers, right? Officially, yes. Should you check it in both equations? Yes. Here's a tip, though. You don't really need to. Because I am 99.9% sure that this answer, because we got it from this equation, will definitely work in this equation, right? Where would actually be the best place to check your answer? If you check it in this one and it works, you can be pretty sure that you got it right. So 4 times, this would be negative 4, would be negative 16. Negative 5 times negative 5 is positive 25. Does that equal 9? Yes. I'm pretty sure we got the right answer there. Okay, so officially, yes, you should check your answer in both. But honestly, you don't really need to, because wherever you got this from, the second answer, if you just check it in the other answer, you can be pretty confident you got it right. So, comparing this method to the graphing method, better or worse? Well, let's try one. Everybody write this one down right here. Ready? Let's do x plus 2y is equal to negative 1. And we've got 4x minus 4y is equal to 20. What's step number 1? What's the first thing I want? Say that again. Get x or y by itself. Is there an easy spot to do that? Yeah. Where? First equation for which variable? I'd get this x all by itself, right? So, instead of x plus 2y is equal to negative 1, what's x going to equal? Negative 2y minus 1. Just got to move that to the other side. So step 1 is complete. What's step 2? Write the other equation, 4x minus 4y is equal to 20. But what are we going to replace? This is equal to x, right? So I can replace the x with the negative 2y minus 1. What's the next step? Distribute. So we got, let me rewrite this a little bit so it's a little easier to read. Negative 2y minus 1. Okay, distribute. 4 times negative 2y would be? 4 times 2 is? So negative 8y minus 4 minus 4y equals 20. How many y's do I have? But what's negative 8 minus 4? Combine those, that'd be negative 12 minus 4 equals 20. So you get negative 12y equals 24. Divide and you get y equals negative 2. So what part of my answer do I know? I know the y value is negative 2, right? How are you going to find the x that goes with it? Plug it in. You can plug it in here. You can plug it in here. Or I would plug it in right there, right before you substitute it. What is negative 2 times negative 2 minus 1? 3? And there's your answer. Now, again, should you always take the time to double check your answers? Yes. Again, you don't actually, which of these two equations really would be the best place to check your answer? The first one or the second one? Second. Why the second and not necessarily the first? I know it's going to work in the first because that's where I plugged it in to get the 3. If it works in the other one, I can be 90% sure. I can be 100% sure if I plug it in both. So if you just plug it in, 3 times 4 is 12. Negative 4 times negative 2 would be positive 8. That equals 20. Yep. I can be 90% sure I got the right answer here. Okay? Easy enough? So as far as comparing this to the graphing method, better or worse? Huh? Is this a really quick method? No, it's really not. And sorry, guys, I can tell you right now, there's never going to be, most of the time, for a lot of these types of problems, a super fast way of doing these. There just isn't. So these are problems that are going to take a little bit of time no matter what method we use. As far as right off the beginning, when would be the only time you would want to use the graphing method? Both of them are in slope-intercept form. What if we had a problem that was already both in slope-intercept form, like y equals x plus 3 and y equals 2x plus 4? Would the graphing method be a good method? Sure, I could do that. But I could also use a substitution method. Do I have an equation that's already solved for x or y? I got two of them, don't I? Great. Let's substitute this one into this one. I get to write y equals 2x plus 4, but I'm going to replace the y with x plus 3. If this equals y and this equals y, what has to be true about both of these two things? Don't they have to equal each other? So I got x's on both sides. I would subtract the x over to here, so I'd get 1x. I might subtract the 4 over to here, and I'm right away down to where I have x is equal to negative 1. I'd plug it in right here. What's negative 1 plus 3? 2. Was this problem a lot easier? Why? They're already both solved for y. It was an easy substitution. This was guys, there is going to be problems that are fairly easy to do. They're not all going to be complicated multi-step problems. But I will tell you this. There's no way anybody, I don't care who you are, no way anybody could take a problem like this. This is, maybe this was number 8 out of the book. If your paper looks like this, yeah, no way. Can you do this method without showing work? Huh? Yeah, you're going to need to show some work. Yeah. You can't just write answers. You just can't. Like, it's just, no, sorry. You can't just write answers. There's no way that we can, even on a problem like this, doing that in your head, this one, there might be 2 or 3 people that could do this in their head. This one, yeah, I can't do that in my head. So, sorry. As far as, is one method better than the other? I think this one's, I'm more likely to use this one because what's the only thing I'm hoping for this method? One easy x or y, right? I needed one problem where I can get x by itself or one problem where I can get y by itself. That's going to be a lot more common than a situation like this one where they're both in slope-intercept form. This is an easy problem. I don't care if you do this problem substitution method or graphing method. If the problem was y equals x plus 3 and y equals, what was it, 2x, was it plus 4? Graphing method, this is not a hard problem. Start at 3, 1, 2, 3, up 1 over 1, right? Great. Start at 4, up 2 over 1, up 2 over 1, up 2 over 1. So down to back 1. Looks like that's going to be the answer right there at -1, 2. Is this method easy graphing? Is this problem an easy graphing problem? Yeah. Is it also an easy substitution problem? It's easy no matter how you do it. Some problems just are easy problems. Some problems are a little bit more difficult no matter how you do them. Like that's just life. Like you're going to run into problems that are a little bit harder to do. This method, I think, is way better than the graphing method. What is the biggest downfall of the graphing method? What? Sometimes it's hard to be precise. With this problem, if you run into a problem where the answer is ugly, like a decimal, are you going to be able to find that precisely with this method? Yeah, this will spit it out. It might be an ugly problem. Instead of 25 divided by 12, or 24 divided by 12, it might be 25 divided by 12. So it becomes an uglier decimal, but you can still do it. You'll still get the right answer. It just won't be a nice, pretty answer like this one. And that's okay. Fair enough? All right, everybody take a look at page 394. Yep, I know, we're getting homework.